हम्म, क्या-
Evening, sir.
Okay, good evening to you all. Good evening,
Sir.
Yukta. Good evening, Pranav. Good evening, everyone. See, you people should join quickly. Be quick in joining. If all of you join quickly, I will end up your class 5 minutes before. Okay? If you join the class quick, I will try to end up your class 5 minutes before also. Okay? So be responsive, be active during the classes, try to answer the questions, right? Whatever topics is being done. So you try to be a part of that class. All right? Okay. So another uh, topic. See, in physics, there are three main topics. There are five chapters, basically. Out of those five chapters, we have completed motion and we have completed laws of motion. And since most of you must be getting only these two chapters as your syllabus, okay, you should be getting only these two chapters. Just check if there is anyone who is also getting in the Newton's in the laws of motion. If you are also getting the momentum and conservation of momentum, right? Like, have you done those questions of bullet uh, recoiling? With what velocity does the bullet recoil? See, as that part, I can check that part has been deleted from CBSE. But still, if some of the schools, like your school or your teacher has taught that, so we'll continue that. If not, we'll leave that. However, most of your teachers should have left that portion. Okay, so I don't want to create a confusion in your minds. Like, yeah, if you do it unnecessarily, so it will create a problem, right?
Good evening, sir.
Yeah, good evening. So, is there anyone who is getting that conservation of momentum also? Yeah, is there anyone who is getting that conservation of momentum? No. Okay, so that's a good thing. We have done with the Newton's laws of motion. We were trying to do the questions from NCRT. Today we'll complete the questions from NCRT and some other parts also. So this will end up the chapter. Apart from that, we were discussing some of the assignments. So you should be participating in that. You should be solving those questions, right? So if I give some assignment, you should try to solve that assignment. So just let's see, solve some questions from NCRT. In the last class, we had done a few questions based on this. Okay. Also, I would like to do this question from the graph. The question relates motion and this chapter. So it's a very important question from this chapter. Question example number 9.5. Okay. So first of all, I would just like to hear your ideas. How can this question be solved? And then you can continue to solve on its own. You see, just go through the question, everyone. Go through it. The velocity time graph of a ball of mass 20 grams moving along a straight line on a long table is given. Okay. So have you gone through this? Yukta, Pranav, Jitendra.
Yes, sir.
Yes, sir.
Okay, so can you tell how should we start solving it? How should we start solving it?
Sir, should we first try to find the acceleration of the body because we have the velocity and time and the mass? So we can find the force by finding the acceleration and multiplying the acceleration with the mass.
Yes, so from the graph, we will find out the acceleration. Okay, once we find out the acceleration from the graph, we will find we have been given mass here. We'll convert mass into the SI units and then obtain the answer. So within 2 minutes, I shall see the answers now. Okay, Pranav.
Yes, sir.
Okay, try to solve this. Obtain the answer. So all of you will first tell me the value of acceleration that you obtain. First, tell me the value of acceleration that you obtain.
Minus 2.
Minus?
Minus 2 meter per second.
Okay, see, you can observe it in a number of ways. Either you find the slope of the graph. This is a velocity time graph. So to find out the acceleration will be equal to the slope of graph. So either you find out its slope. Okay. So slope is given as perpendicular over base or it's given as rise over run. So there is no rise, there is a fall in the graph. So fall will be taken as negative of rise. You write negative and that fall in the graph is equals to 20. So you write it here, 20 centimeter per second. See, it's 20 centimeter per second. So you must convert this to meter per second. It's 20 centimeter per second. See, so its velocity or change of velocity is negative 20 centimeter per second and divided by time, that is 10. So you get this answer as negative 2 centimeter per second square. As the SI unit of acceleration is meter per second square. So you convert this to meter per second square. Okay. So centimeter converted to meter by dividing by 100 and hence you have negative 0.02 centimeter per second square as the acceleration. Then mass is given as 20 gram. So we obtain force.
0.02 meter per second square.
It's centimeter. I can see a centimeter. Just,
Okay.
just check it. Okay, I'll just confirm it by checking the solution. See here it's centimeter, right? Can you see it?
Yes, sir. So we
Okay,
have to
okay.
convert the acceleration into meter per second square.
Yeah, you need to convert it to meter per second and then solve. Okay. See, also we'll see here. Just let me check it with the solution of the book. It may be a misprint. So if it's a misprint or it's correct. Yeah, it's same. It's 20 centimeter per second. So you need to convert it to meter per second. Got it? So there is no misprint. It's correct. So acceleration is negative 0.02. The mass is given as 20 gram. So 20 gram converted to kilogram, it makes it 0.02 kilogram. Got it? So force we get as 0.02 times 0.02, and hence the answer becomes 0.0004 Newton. You can convert it to a CGS system also by converting it to dyne. So in dyne, you will be getting this force to be equal to 40 dyne, as 1 Newton is equal to 10 to the power 5 dyne. So you can convert this, it will be equal to 40 dyne as the
So
answer.
wouldn't be negative?
Yeah, it's negative.
Okay, sir.
Since acceleration is negative, so this is negative. So see, so this is negative 0.0004 Newton. We'll try out one more question. Okay, so in the last class, we had done question number 10. Did we do question number 11? Okay, so leave question number 11. I think for the current syllabus, it's not there. And we need to do question 12, question number 14. Yeah, let's do question number 14. It's a very interesting question. Just go through this question number 14 and we'll try to solve question 14 now. All of you go through the question, see what's given, and then answer. Okay. If you are not able to find out the solution, if you do not understand the question, just raise your hand so that I know you haven't understood. From the question, find out the quantities or write down the quantities which are given. So write them with their symbols, with their correct units. Whatever information you gain from this question, write that information in the form of symbols. So the bullet has a mass of 10 grams. Okay, I think everyone has understood and everyone can solve as no one has raised his hand. So Sharwan will tell now. Sharwan,
Yes, sir.
okay. Can you tell the answer for this?
Okay, sir.
Okay, what
The
all
first,
information is given? What all
the
information is given? First tell me.
mass of the bullet is 10 grams.
Okay, so we write here the mass of bullet.
So it's
M.
0.01 kg.
Okay, it's
Then
in
initial
gram. Okay, just 1 minute.
then initial velocity should be 150 meter per second.
0.01 kilogram. Okay, initial velocity u is 150 meter per second.
Yes, sir. Then the velocity is 0.
Okay, final velocity v as 0.
So then time equal to 0.03 seconds.
Time is equals to 0.03 seconds. Then what we have to
And now
find out? What else? What all things we have to find out?
So you have to find the magnitude of the force exerted by the wooden block on the bullet.
Also, one more thing. See, calculate the distance of penetration. So that is displacement we have to find out, and then we need to find the force.
Okay.
So to find the force, you must be having acceleration. So you can use acceleration and then obtain.
Okay.
Okay. So I want to find out here displacement. Now, which equation of motion will be used?
Sir, S equals to UT plus half AT square.
Yeah. First, we find the acceleration. The acceleration will be v minus u over t. Right. So v is 0 minus u is 150 divided by time, that's 0.03. So it's negative 150 divided by 0.0. You get this answer as 500. So negative 5,000 meter per second square as the acceleration. Yes, got it, everyone? Everyone got the acceleration?
Yes,
So
sir.
once you have obtained the acceleration, then we will use the equation of motion. Okay. Then we'll use which equation of motion will be used to find the displacement?
So
Which
there are
equation?
two equations. First one UT plus half UT square.
Okay. So we can use the second equation also,
Second
or we can
equation.
use the third equation also. By both of them, we'll get the same. Also, the values which are known, they can be used in both of them. Either use the second equation or use the third equation of motion. So if you want the third equation of motion, see, for the third equation of motion, you can use v squared minus u squared to be equals to 2as. So v, the final velocity is 0, minus u, the initial velocity is,
Sir,
yeah,
sir, will we get distance in also decimals?
pardon.
Sir, will we get the distance in decimal form?
Okay, just let me check. You have 150 squared times equals 2 times of acceleration. So acceleration was 5,000, a negative 5,000. So you get this negative and times displacement. So yeah, you'll be getting this in decimal only. So you get negative 22500
Sir,
divided by negative 10,000 equals displacement. So this is not 5, this is displacement. Okay. Don't consider it to be 5, it's displacement. So negative and negative cancel, 2 of the zeros cancel, and you can put the decimal as 2.25. meter. So the displacement is 2.25 meter. Did you get this answer?
Yes, yes, sir.
Yes. So the thickness or the displacement of penetration, distance of penetration is 2.25 meter. Now find out the force also. For the force, you will just say mass times acceleration. So what is the mass given?
Sir, 10 grams.
Yeah.
10 grams.
Okay. So use that mass. Force will be equals to mass times acceleration. The mass was given as 10 grams, so it's 0.01 times acceleration, that is given as 5,000. So you get, I think, 50 Newton as the answer. Yes? Is this correct?
It will be negative 50, no, sir?
Yeah, negative 50 Newton. Okay, it's negative 50 Newton since acceleration is negative. So you get the answer as negative 50 Newton. That means this is the resistive force offered by the block. Okay. Any other doubt here?
No, sir.
So this, now let's try to do question number 15. Now we take question 15. Let's try to solve. Okay, we'll leave question number 15. Question number 15 is from conservation of momentum. Okay, we can do question number 16. Okay, let's try to do question 16 again. Okay, do question 16 now. And those who are not able to get it shall raise their hands. Okay, so all those who are not getting their answers, they should raise their hands.
Sir,
Yes.
sir, in the before question, when I use the second law of motion, I'm not getting the right answer.
Okay, let's check it out. I think you are using S equals to UT plus 1 by 2 AT squared.
Yes, sir.
Okay, I'll solve this with your method also. Okay, so let's see. I need to find the displacement S. So displacement S will be equal to UT plus 1 by 2 AT squared. So S will be equal to U, that's initial velocity is 150 meter. How much is the initial velocity? It's 150, right? So it's 150 times T, which is 0.03, plus 1 by 2 times acceleration, which is negative 5,000, multiplied with T squared. So T is 0.03 squared. Got it? Yeah, is this the same thing?
Yes, sir.
Okay. Okay, everything is correct. So if you multiply 150 by 0.03, you are getting 4.5,
Yes, sir.
and plus you get here 1 by 2 times of negative 5000 multiplied with 0.0009. This is what you will get. It will become 4 decimals. Currently, you have 2 decimals. After the decimal, you have 2 places. So now you'll have after the decimal 4 places. Okay. So now if you multiply this 9 by 45, so let's see. All the three zeros vanish, and you multiply 9 by 5, you get 4.5. So you get 4.5 plus negative 4.5 divided by 2. So you get 4.5 minus 4.5 over 2. So 4.5 over 2 is 2.25. This is also 4.5. So subtract it, you get answer as 2.25 meter. Now it is correct. See, it's the same thing, 2.25.
Okay, sir.
Where did I think you might have done error in making the square of 0.03.
Yes, sir.
Yes.
I took it wrong.
Okay. So now try out this question. Everyone. Okay. Is there anyone who is not able to get what we have to do here? Anything you want help in this question? Okay. What all different values are given here? Okay. So the mass is given here as 100. Mass is given as 100 kilogram. Okay. Initial velocity is given to be 5 meter per second. Final velocity v is given as 8 meter per second. So you need to calculate the initial and final momentum of the object. So here the initial momentum is mu. Also find the final momentum, and in next 2 minutes show me the answers. So I hope okay. Is there anyone who has got the answer? Those who have got the answers.
Sir, I got a mail sent you, sir.
Which one?
Sir, I sent my answer to you.
Okay, so I got 4 people's answers. Okay, let me check it. Okay, Sampath has sent the answer. I will need to open it. Okay, it's 100 minus 100 over 5. Okay, 500 then divided by time. Yeah, it's correct. Okay, you get 300 by 6. The time is given as 6, I hope. Yeah, so you are correct.
Okay, sir.
Initial 500, final 800. Okay. Jitendra, you are using incorrect units of momentum. So we obtained initial momentum Pi to be equals to mass 100 times of initial velocity 5. That's 500 kilogram meter per second. Then final momentum is 100 times 8. That is 800 kilogram meter per second. Change of momentum will be final momentum minus initial momentum. So that's 800 minus 500, which is 300. Then you need to find the force. Force can be given as change of momentum per unit time. So change of momentum delta P is 300 divided by time, that is 6. So you get 50 as the answer. Got it, everyone? This is 50 Newton. Okay. So today almost everyone was active. Just let's see. One more question. So see, Akhtar, Kiran and Rahul were riding a motor car. Pointer. Mouse pointer. Pointer. Mouse pointer. Pointer. Okay. So see, you just go through this question 7. It's an oral question. Okay. So go through it and let's see if you can answer this. Question 17. Akhtar, Kiran and Rahul were riding in a motor car that was moving with a high velocity on an expressway when an insect hit the windshield and got stuck on the windscreen. Akhtar and Kiran started pondering over the situation. Kiran suggested that insects suffered a greater change in momentum as compared to the change in momentum of motor car, because the change in velocity of the insect was much more than that of motor car. Akhtar said that since the motor car was moving with a larger velocity, it exerted a larger force on the insect, and as a result, the insect died. Rahul, while putting an entirely new explanation, said that both the motor car and the insect experienced the same force, okay, and a change in their momentum. So, who is correct? Pranav? Pranav, who is correct? Pranav? Pranav? Pranav, are you there? Okay, since Pranav is not responding, so I'll just send a group message to him now. See, you must be responding to the group. When your name is called, you should be responding if you are there. Jitendra?
Yes, sir.
Jitendra is active, only Pranav is not active. So Jitendra, what's the answer for the 17th one?
Sir, I think Akhtar and Kiran were right.
Yeah?
Akhtar and Kiran were right.
What you are getting?
Sir, Akhtar and Kiran were right.
I think here Rahul is correct. Okay. Both of them, they experience the same amount of force due to action and reaction. Because action force is always equal and opposite to the reaction. So both of them, they suffer the same amount of force and same amount of change of momentum also. The boat has a greater mass, so it experiences a small, the same force, but there is a small change of velocity. Whereas for the insect, its mass was very less. So as a result, it experienced a large change of momentum and hence a greater force. So students, just due to some urgency, I'll be joining, we'll discontinue the classes right now. We'll continue in the next class. Okay, bye all of you.
Bye.
Thank you, sir. Bye.
Just ending the class just now.